So let's take a look at the law of cosines. That is something that relates the sides and an angle of a triangle that does not have to be right angled. So it's a little bit different from regular trigonometry in that regard. So you've got c squared, that's the square on this side here, is equal to the sum of the squares on the other two sides, so a squared plus b squared. It's just like Pythagoras so far. But this is not a right angle, so you have this extra corrective term that you have to subtract, minus 2ab cos theta, where theta is the angle that's opposite this side c. Now, if you look around, you'll find that there's a lot of proofs of this in textbooks and online. They tend to be a little bit messy, have a lot of algebra in them, and there's nothing in them visibly corresponding to this corrective term here, 2ab cos theta. I mean, this is geometry. We should be able to see some shape that actually has that size. Well, let's see if we can do that. Okay, so the way to start is by going back to the plain old Pythagorean theorem. So here's your standard right angle triangle Pythagoras. So a squared plus b squared is c squared. That's pretty normal. But what happens if we change this angle theta? So theta is actually going to get smaller, but these sides a and b are going to grow. Let's have a look at that. Okay, so there they are growing. Well, now, because they grew longer, c squared is not a squared plus b squared anymore, right? It's not as big. We have to subtract off this difference term. The difference is how much a squared and b squared grew. Well, let's take a look at how much they did grow. We'll have a look at b squared first. Okay, so to do that, what we really want to do is simply just have a right angle here. So here's another right angle triangle. B used to be this value, B old, and then it stretched out and became this value, B new. And we want to figure out what is the difference between B old squared and B new squared. Okay, well, we've got Pythagoras again, right? We have a right angle triangle. We want to figure out the difference between the squares of two sides. So b new squared minus b old squared is just the square of the other side. It's this purple square here. All right. Now, let's keep that in mind because it's going to be handy in a minute. That's how much b squared grew. All right, well, let's have a look at a squared next. All right, well, a squared grew from this smaller green square to this bigger green square. And let's have a look at the sides of that, see how much they grew. Well, we've got this red part here, right, this rectangle as part of its growth. And the height of it is just a, because it's part of an a by a square. Well, what about the width of it here? Well, we've got this side here that is adjacent to the angle theta, and the hypotenuse is b. So this width is just b cos theta, right? And that means that the area of that red rectangle is ab cos theta. That's pretty similar to our corrective term. And wait, we actually have two of these, right? Because a squared grew by this part and this part. Oh, so now we have 2ab cos theta. That's great. That's our corrective term. Oh, but there is a problem. Those two rectangles overlap, right? So the difference in how much a squared grew would be 2ab cos theta if it wasn't for that pesky overlap. But wait a minute. That's just looking at how much a squared grew. But we want to know how much a squared plus b squared grew. And b squared grew, remember, by that purple square, which is exactly the same size as that overlap. There it is, right? So if you want to say how much did a squared plus b squared grow, it grew by these two rectangles, which are just ab cos theta, minus the overlap, plus how much b squared grew, which is that overlap. Okay, so when you put that all together, all right, you get that a squared plus b squared did grow by exactly twice the amount of this red rectangle, 2ab cos theta. When theta was a right angle, c squared was just equal to a squared plus b squared. When it changed and a and b grew so that it's not a right angle anymore, now it's equal to a squared plus b squared minus 2ab cos theta. So that's the law of cosines. And that's why it is that way. Well, I hope you like this more geometrical and hopefully more intuitive way of proving the law of cosines. Thanks very much.